Okay, we're going to continue on rationalizing denominators, but this time we're talking about a quotient that has a monomial. Okay, that's in the denominator. So let's take, for example, let's do this. Simplify 8 over the square root of 5x. Okay, again, the whole idea is that we need to get rid of the square root, right? We need to get rid of the square root of the radical, right, in the denominator. Denominator. Okay, and so to do that, we have this. Remember that when you multiply the square root by itself, you basically get rid of the square root side, right? So you remember, if I do something like 5x times 5, square root of 5x times the square root of 5x, that just gives me 5x. Okay. So let's go ahead and do that. So I do the square root of 5x, multiply the denominator by that, so that'll give me just 5x, right? But I can't do that without doing the same thing to the numerator, because this basically equals square root of 5x over square root of 5x equals 1, right? That equals 1. So I'm not changing the value of anything. So then I'm just left with 8 times the square root of 5x all over 5x. And that's my answer there. Okay, let's try another one. So let's say we had simplify the square root of 3 all over the square root of, let's say, 2z. Okay, now again, I need to get rid of this radical sign. So by doing that, to do that, I just multiply the denominator by the square root of 2z, which will give me just 2z. So I've removed the square root sign, and I need to multiply the numerator by square root of 2z, right? So since they're both under the radical, I can just do a multiplication and I get 6 square root of 6z all over 2z. And we're simplified because neither 6 nor z has a perfect square factor. So that's my final answer.